Good afternoon. So, pretty much the last day of the conference, and I'm standing between you and your lunch. And I think it's too early for the lunch, right? Um, I have lots of buzzwords here. Believe me, it's not going to be only the buzzword, it's going to be a lot of action. Just to get a pulse of the audience here, how many of you are really doing some attacks on AI or, or playing around with AI or working in AI? Okay, okay, a decent size. And I can predict next NullCon will have a full of this. The way the security industry is moving, the way the AI is getting into the security industry, I can see that there is a lot more need to make sure that the AI models which have been produced by the defense are strong, right? And they are, they would be actually defend us. So let's get into a little bit, I'm just trying to buy a little more few moments here and few minutes till, few folks come in. And, so-called, let me talk a little bit, who am I? I thought, just the regular stuff. I'm more of a data guy. I mean, I'm here to learn from you more about hacking and more about the attacks, what you guys do. So now, last NullCon, I was here and sitting just like you guys on that other side, and wonderful to be here on the stage and sharing my experience at the intersection of AI and the security. So I've been in security and the AI from last 3-4 years. Before that, I worked in multiple domains, worked in General Motors, Samsung, and so on. I don't want to give my resume here, but the goal is that just to give a little bit of introduction about me, and I'm pretty sure that after the talk I would learn a lot more about the security from you. I'm also a rock climber. If you want to figure out where to climb in Bangalore, what are the rocks, and all such things, talk to me also. Okay, so how are we gonna run the show? First thing is I'm gonna talk about the problem. Spend a little bit time and go a little slowly on the problem. Then get into what should be an approach, okay? And believe me, it's not a product talk or something. It's more of an approach. How would you really solve that problem? And I'm going to give one approach, and you may have more, okay? And I would be happy to listen. And then we'll get into some demos, and then I will get into under the hood, okay? So that like you can take away some lessons from here, and when you go back, you can actually experiment with some data on your own. That's my game plan, okay? So let's get started. So let's talk about a problem. This all started with a question in mind. Can we play a game with an adversary? It sounds like a little more like a childish question in a sense, like, are you saying that playing a game? When you say a game means like it's not a chess game or soccer game or something where you really know your opponent, you as a defender and opponent, you know each other. But here we are talking about somebody, an adversary, who's a mysterious character, right? I mean, the guy, it has its own forms. It's not really a human being. It's a malware, botnet, or whatever you talk about, ransomware and so on, right? And we are talking about playing a game. So I took this question and started asking this question to my colleagues, also Chris Roberts. He also works with us at Acalvio. And one of the hacker. And he told me, maybe Satnam, your question needs to be a little bit altered. It's not really a game. You are saying that can we engage with an attacker? Maybe just a word change, but it's a big change in that word itself. What it is saying is there is a psychological and a tactical strategy war. between adversary and a defender. And if you want to do that, you have to ensure, first of all, that there has to be a visibility about the adversary, right? So let's understand a little bit more about the adversary, right? I mean, you guys are the best, right? I mean, you have been doing all this, the red teaming exercises and more in the purple team and many other teams, right? What I'm trying to say here is when you play a game, at least the opponent's action, the strategy should be visible, right? And in this case, here is an adversary who is sitting somewhere on the remote part of the world, using multiple exploits, using the same tools and tactics, which we as a defenders, we use it, right? He knows a lot more about us, and we know little more about him. So, as a defender, we need to ask second question as well. Okay, if I want to play a game, let's say, I have, few years from now, I have the state-of-the-art AI and whatnot. I do need to figure out that is he the returning guy? Am I talking to the same guy, or am I talking to the same threat? How can you figure out that? Well, again, you have to use the footprints he has left, right? The TTPs he has left. When he is there in the network, he has to do two things, right? No matter what. And you may relate it more. I don't think I need to preach you guys. Number one, you have to figure out where you are, right? Since you have landed somewhere, you know where you are. You have to figure out. And then the second thing is, as an adversary, you want to know where you want to go, and how you need to do the lateral movement. And during this process, you're going to leave some signal over there. And thankfully, to the adversary, that signal is embedded in lots of noise, right? Because even if you look at all the network logs, all the endpoint logs and whatnot, right? It's so hard, right? Everything boils down to the anomalies, and it leaves it very, very difficult for the defender to figure out that where is the adversary. So let's come back to the game. We want to play a game, right? So in that game, if it is like a chess game, adversary and defender. There are two players. You have the moves well defined, right? Your state space is defined. What all movement can be done is defined. In this war game, it's not defined. It's all open, right? If you look at the vulnerability space, you can start from anywhere, right? From the web security to the network security to the endpoint security, and you name it, right? The attack surface is huge, and the state space is huge. So you need to define it. We need to constrain it. As a researcher, and you come and say, Satnam, I want to do that game. I am a PhD guy. I am so and so. I just want to do this next simulation. I want to do this game. How do I do it? I need to define that. I need to define some boundaries. So in this research, what I'm proposing is, let's latch on to the MITRE attack matrix to define what are the tactics and techniques adversary can use. Okay? So how many of you have used MITRE attack matrix? How many of you have used? Okay, very few. So I'll just give a brief introduction about the MITRE attack matrix. I find it very, very useful. If you want to get a meta level information about attackers' tactics and techniques, this is a framework which has been built by the MITRE researchers over years. And it has a rich information about what kind of tactics and techniques adversaries use. And then another good thing is, the initial part of the attacker's activity, which is primarily the social engineering part, and how he lands into the first so-called victim, and move from there. that part is not really covered, but the rest of the part where he's doing the control and the execution and he's maintaining the footprint has been well covered here. So let's get into a slightly more detail into this attack matrix, and then I will come out to the game again. So this is the more of a deeper slide on that. What it is saying is the tactics are there on the row wise, and the techniques are listed on the column wise. And the good thing, what as a defender you can do is you can watch, you can figure out what footprints he has left, what are the logs he has left, what anomalies he has left, and you can map it out to the techniques and the tactics. See, for an example, this one shows for APT30. There are different colors which shows the heat map. So APT30, it shows that the APT30 they have used the login scripts in persistent, and you just follow the blue color there. And then, they have used the DLL side loading for the defense evasion and so on. Okay. So what my point here is, as a chess game, right, you knew what are the things which are possible on the board, right? Here, we are saying is, as a defender, if I can say that the adversary is going to do only these many tactics and these many techniques, okay, then I can map it out. But the question still remains, do you want to play a game? I'm going to use the word game here, but it could be engage and, or so many other words. But let me stick to the word game. You want to play a game. That means you need to have visibility, right? So the question comes that, do I have a visibility, right? In the current scenario, do I have a visibility? And all of you guys know that, like, we have almost like very less visibility of the adversary within the network. All we got is a perimeter. The perimeter is broken. Everybody knows that. And whatever is still what we are using it to control the perimeter only. All the things what we use, IDS, IPS, or say firewalls, you need them, but they don't give you the visibility within the perimeter. It's like a fort, right? Once you have a credible, just an iCard or something like which has been issued to you, and you just walk in, and that's what the adversary also does, right? But once you are inside the fort, you can do whatever you want, and the same thing adversary also does, and you guys do that as well in your red teaming exercise, right? So the point I'm trying to make is you need to have the new tools to have a visibility. So what can we do to get that visibility? And I'm proposing here two things. Okay, you can have something more and get back to me, and I would love to hear from you. Number one is deception, and number two is AI. And actually, just one alone cannot solve the problem. And I will make my argument why. So let's talk about a deception for a minute. How many of you have experimented with honeypots or deception as such? Awesome. That looks my kind of audience. So I don't need to get too much into the detail of deception, but let me just give a very high level view of that. It's a reincarnation of honeypots. Honeypots used to be static, and as a red team or as an adversary, whatever, you can easily figure them out, just by looking at the host name or by looking at their, just fingerprint them. Fingerprinting them was quite easy. And most of them were deployed at the perimeter, facing internet, and collecting a lot more threat intelligence information. Now, you take those honeypots, but you have to rewrite them. You rewrite in a way with the software-defined networking in a way so that it is scalable for the enterprise and so on. but it should have a variety. It should have blending capabilities so that it blend well with the environment. So what do I mean by that? So if you look at this particular example of an enterprise, it has been, network segmented. It has various network segments, for example, operations, engineering, sales, and so on. And if you create the device, the deceptions, the low interaction or the high interaction, it should have the properties which are matching with that particular network segment or for that particular enterprise. It's not like, you take the antivirus and you ship the same AV copy to everybody. It can't be. If when you're saying a deception, it has to have that magic for different for each one and different for, it has to be contextualized for that enterprise, for that VLAN, for that network segment. What do I mean by that? It has to have the network host name, it has to have the Mac OUI, the services, all that blending well with that network segment. Now, that SDN layer or the deception layer, that can't do it alone. You need to have AI there. So AI plays a role over there. And I'll get into the detail of that as well. Now, let's say as a defender, what you do is you put a whole bunch of low interaction, high interaction, and the browser cookies, the breadcrumbs in terms of RDP credentials and many such things, different types of deceptions you play out, right? Now I have something which gives me, as a defender, it gives me a tool which I can play a game. And I'll show you, I'm not preaching, I'll show you. Maybe, a little more futuristic, but I'll show you with some demos. Now, the second thing is, once you got your deception played out, adversary comes in and he bumps onto one of those deception, one of those honeypot or honey token or whatever you say it, right? You get an alarm. And that alarm, you take that and get a lot more contextual data around it. And then, you give that insight to the defender. Now the defender can actually take that and play a game, in a sense like he can allow whether to let him go further or cut him off. So let's get into the demos, and this will give a little more clear picture what I am talking about here. So here is the scenario. I showed you one enterprise, right? The network, example network, in which there were various segments and there was a sales segment as well. So my colleague is sort of acting like a red team guy, an adversary. He is trying to exfiltrate the data eventually, but before that he is trying to know the land. So he's running Nmap, and the defender has to watch him and figure out what he is doing. So I'm going to play out the video and explain that through the video. Okay. All right. So what adversary is doing is he's running that nmap command, and it may sound like a very childish here, but you can run any variations of it so that you don't you can spoof your MAC address and you don't show up the many things and whatever, right? But the goal here is, in this particular exercise, what adversary has done, for a particular IP range, he is trying to see what ports are open, what can I, what is where I can go to get, what I want to get from the sales network, from there, the sales network segment. So what he finds is he finds an RDP port open, and from that SFO gamma host, and the next thing is obviously, as a defender, we have to see whether we have detected that nmap or not, right? So let's see that. So as a defender, we got this alert on the defense side, and we are able to detect there is an intruder here, and he has done a scanning activity, and from which IP address he is coming, and so on, right? And what we can do is at that time itself, we can actually spin off one of the high interaction. That since he is there in the sales VLAN, we can spin off bunch of high interactions over there, high interaction decoys, and see whether adversary comes over there. Okay, and we can also leave some of the credentials, sprinkle in that VLAN, and if he picks up, then he may end up being into a high interaction, so that we can watch him. So let's do a second part of that. So the video 2 or the scenario 2 is what adversary does is he takes that particular host and the IP address, and he does an RDP to that, and then he figures out using one of the credentials, or one of the brute force attack as well, gets into the host and runs an obfuscated PowerShell command. So I just picked up this particular scenario here because last time when I was here at NullCon, I saw a talk on doing the PowerShell obfuscation, and it was very fantastic. So I thought, can we do machine learning and AI to detect it? So I picked up this particular scenario where adversary is doing the obfuscation, and then as a defender, can we watch him and can we detect that? So let's run that particular attack. So this is an obfuscation. It's a simple scenario. We can actually elaborate the attack scenario as well. What adversary is doing is he is actually calling the obfuscation tool to obfuscate the PowerShell script. And in this particular demo, he is just going to obfuscate a very simple command, store it in a file, and then execute that. So I'm just going to show the steps for that. He's using a script block from this obfuscation tool, and he wants to obfuscate the service. He wants to know what all services are running. So first obfuscating that PowerShell command, and then execute that. So he got the obfuscation here. That obfuscation he has stored it in a file, or it can be run in a memory as well. In this case, it is stored in a file, and then he's executing that PowerShell script. Okay. So, and he's gonna just run that obfuscated PowerShell script. All right. So let's continue with that. And the next thing is what he wants to do is, and I will show you that as a defender, that are we able to detect that or not. The next thing he does is he actually takes downloads the PowerSploit and Mimicat, and then use a LSAS dump and a Mimicat to extract the credentials, and then exfiltrate that using a DNS tunnel. So that's the game plan here. So let me show you that what adversary is doing here, and then then I will also show the defender as well. So what adversary is doing here is he is importing the module from the PowerSploit to get the LSAS dump, and he's getting that LSAS dump, and he's already there. He came earlier, right? And right now he is trying to move that file on a particular folder here, and then there he's going to run the Mimicat. So he's running the Mimicat now, and getting the credentials into a pwd.txt, and he got that from the LSAS dump, and got the credentials, and those credentials are here in the PWD file here. Okay. So let's see. We saw the attacks. Now let's get into the defender side. Okay. So now, as a defender, you have instrumented whole bunch of cameras there. You are watching him, but we are talking about a security analyst who is actually buried in analyzing all the anomalies and the alerts. A typical number of alerts he investigates in a day is roughly 10 to 11, and but what he gets is 100 or 500, right? Now you're telling him to do all this and look at all the logs, and I'm just going to play this. Like, the amount of log it creates is huge. The logs are coming from the processes, from the service changes, from the registry changes. You're watching everything, all the commands, what he has done, the keylogger activity, everything. You're watching that, right? It's a huge data. Now, nobody's just going to sit and watch. So you need to convert that into some meaningful notables where the analyst can look at, where the defender can actually look at, so that he can really play a game, right? So so this was the raw data, but now let's see a summarization version of that. So this has been summarized. So what you saw over there, it was like, I just played a glimpse of that. That was like some 60,000 or some, these numbers become insane depending on how much you run it, for how much engagement really happens with the adversary. And what you see over there, that the numbers get converted into just few tens. And here it has been well summarized. So you see that the adversary ran the obfuscated PowerShell command. He also imported certain modules from the PowerSploit. All that has been recorded here. He created that office.ps1 file and he executed that. So everything has been recorded here. And then also it predicts that privilege escalation or exfiltration attempt has been done as well. And all the commands, whatever he ran, all that has been extracted from the logs and well presented here. So now let's get to the last stage of the attack. So now the attacker is establishing a DNS tunnel and exfiltrating it. Okay. So what he does is he downloads a DNS cat2 and then establishes a tunnel with the server, and he has a server which on his own, DNS tunnel.attack, whatever it is, right? tunnelattack.com or something. And he is establishing a tunnel and then exfiltrating the credentials what he extracted in the last step. So I'm going to show that attack, and then I will also show that defender has detected it. So let's see that attack. So in this particular case, what attacker is doing is he already has a DNS cat2 client on the SFO gamma host, which he compromised. And he's creating the tunnel, and the server is at the tunnelattack.com. And now he's gone to the server, and from there he's going to type the Windows I and try to download from the client to the server that particular credentials file. So that's what he's doing right now. He's downloading the pwd.txt from the client to the server, and this shows that activity over here. Okay, so he got that transferred. Now let's see the defender side. So the defender side, we need to detect this DNS tunnel attack activity. So you can see that he has, I'll highlight that here. He got the pwd.txt, which he created. We found that there's a tunnelattack.com that URL has been detected, and The DNS tunnel also has been detected as well. So the defender has detected the attacker's activity here. So I just showed, bunch of scenarios here, and what I philosophically illustrated here, that when you have a combination of deception and the AI, you were sort of like able to play a game with him, with the adversary, because you got the visibility from the deception and you got the AI to surface the signal what adversary left and remove the noise. So you got a combination. Now let me get into the details of AI here. So first of all, I just want to explain a little bit like AI. What I meant here, it has the umbrella of everything. It has the deep learning, the machine learning, the data science, and pretty much everything. And I'm just going to get into the few use cases what I used in this particular in these demos. So adversary, as I told you, right? He has all initially compromised. He landed on a SFO gamma, and then he is trying to exfiltrate the dump. So we got the visibility from the decoys, from the deception alert, and we got lots of signal about the attacker activity, what he's doing, and that we are capturing it from the AI tools, right? So I'm just going to show the few engines what we have built here and what we are using it. So first thing I showed you that the data was huge, so you need to summarize it, right? And if you just look at the summarization problem, that is actually a very tough problem. If you look at the newspapers and you want to summarize it, you know what, the summary technique over there is actually the first paragraph itself is typically the first summary. But in this case, it's very complex. The logs are all different, and they are sometimes they might be repetitive, and few parameters are changing. So what do? You actually first figure out what's the baseline. What kind of things are happening where, which is not changing. So and then you subtract that. So you filter that. And then also you use the domain-based rules and use the NLP to summarize it. And now once you got that summary, now you can give it to the defender to look at it. Just to illustrate, a few incidents, the numbers were in thousands, and we were able to bring them down to just few tens. So that's the power of a summarization. Okay, the next thing you remember, right? As an attacker did a obfuscated PowerShell script execution, right? And then he also executed the Mimicat and the LSS dump and everything, right? So what you can do is you can make a data pipeline. Since you know that what kind of things are possible. I mean, like obviously, if attacker is making his own scripts, I'm taking it as a next level. But if he's using a well-known tools, then we can actually train the classifiers beforehand, right? So for an obfuscation, what we can do is let's take all the scripts. Let's take a corpus and create the character n-grams and do some feature engineering and take that and give it to the classifier. And I'm not really saying that, depending on how much data you got, you can use a deep learning or you can use a regular machine learning. I leave it up to you depending on the various criterias. That itself is a deeper topic. In this particular case, we have been leveraging TensorFlow and ANN for that. And it does a detection of whether it is obfuscated or not obfuscated. The next thing is you have to figure out what tactic and technique adversary is using, right? Because as a defender, when you want to play a game, you need to know where he is. You need to know which state the adversary is so that you can play out the next thing. So for that, we take the power exploit, mimicat, the known tools, and again train the classifiers with those known tools. And then for the unknown script, it will predict what tactic and technique it is. For an example, it will say whether it's a privilege escalation or exfiltration or what tactic it is. The next thing you remember, right? The adversary did the DNS tunnel attack. He established a DNS tunnel and then exfiltrated the credentials. So how can we detect that? We have to make a data pipeline again. In this particular case, we know the tunnels, right? We know what are the possible tunnels we can make as a red team or as an adversary, what he can do, right? So we can use for the known tools, right? Until unless he invents on his own, right? At least for the known tools, we can take those. We can establish the DNS tunnel, do feature engineering, make the features based on flow-based as well, and also from the packet-based, packet metadata-based as well. What do I mean by that? You know, using the domain name as well. You take the n-grams for that, character n-grams, or you want to go more sophisticated, give it to LSTM networks, and you know it will learn the features on its own. I mean, all these are deeper topics. What I'm trying to say is you get your features and now you train the classifier, and when you give it to any unknown attack, an unknown DNS sequence, it will figure out that, you know, whether is there a DNS tunnel there or not. And then it will also say what domain is being used. So wait a minute. I showed you a bunch of videos. I showed you a bunch of attacks, right? I gave you a picture and the vision of the game and all that. But, you know, are you able to really make it as a game theory, or are you able to formulate that? I mean, will it be ever possible to do that, right? Let me make an attempt to do that. So let's define a game here. Okay, what kind of play game? We have to make it a little more simplistic here, right? I mean, if you make the things more open, then, you know, as a researcher, and you want to, you know, make some kind of statistical model for that, you need to formulate that, right? And in those, you have to take certain assumptions. So my assumption is there is an adversary and there is a defender. And if you go to the classical game theory, you need to have action space defined, you need to have the payoffs defined, and those actions and payoffs are actually within certain boundaries, right? We talked about the MITRE kill chain matrix, right? You remember, right? That was actually, we can use that to say what actions adversary can do and what actions defender can do. He can put maybe more deceptions, he can put, you know, more AI tools. Those are the defender's actions, or ultimately, you know, he can block him, right? And the payoffs are what reward functions, what reward values you associate. Attacker gets more rewards certainly when he is able to exfiltrate, and on the same time, when, you know, defender gets more rewards, he still has a control. He is able to detect into various stages, and he gets more and more rewards. And he gets less rewards where he loses the visibility. The visibility goes zero. That time his payoff goes zero. So this is a very simplistic version of it, okay? If you look at the game theory, and this is a normal form of it, you look at it as a matrix, and you look at the rows as your defender, and you look at the adversary in your columns, and you define your payoff values there. And I'm sort of like leaving here, I left it a little more simplistic here, because we do have, you know, much more advanced version of it, where we actually took this approach and we took it for Active Directory use case, and we simulated the game. And I'm not presenting all the details here. That will be, you know, coming in one of the journal paper which we'll be publishing soon. And, you know, I'll share in my tweeters, in my tweet account. But what I want to paint a picture here is when we started, with some scenarios, and now we are able to bring it to a formulation stage where we can say that there is a game being played here. And what is that game? The game here is the defender is able to say that, well, I'm going to allow him in the perimeter. I'm going to allow him to do what he wants to do till I have a visibility. And after that, I'm just going to block it because I can't, he can create a chaos. And I'm going to use the tools which gives me the visibility. And as an adversary, what he's going to do is, he wants to do the attack and he's after something, right? He's going to execute that. And the moment he realizes that he's being watched, he's going to walk off, but he will again come back. He's going to quit for that moment. He will sleep for some time and he'll again come back. So that's the game being played. But is this formulation good for the real world? I mean, certainly. I mean, that's good for the initial few steps for the theory, not for the real world, right? We need to bring some more things. What is that? And can we bring something like AlphaGo? Like AlphaGo, pretty much everybody heard of here, like, the game which beated the topmost AlphaGo player, which learned on its own. Will it be ever possible to play such a game in security space? I am optimistic, but it will be possible only when there is a visibility and there are fusion of different tools which defender has so that he is able to know the tactics and techniques what adversary is using. And then he will be able to play that game. So I'm going to leave with this sort of like an open problem. In the first keynote speech here, what I heard from Harun was saying that it's good to know the open problems and which to pick up, right? And so that you can work on. And I'm going to give you this as an open problem. And you guys are all, security experts here, working as a pen tester and great researchers. This is one of the problems. Come and solve it. It's waiting for to be solved, which is at the fusion of the security and the AI. So what I talked about that we want to play a game, and it is more of a futuristic vision. Will it be possible? I think in the near term, certain things are possible. Use a combination of some visibility tools. And I preached about two tools here, deception and AI. Take those tools, then you get a visibility, and then you establish that is he the returning adversary. And I'm pretty sure one of you are going to ask me, how do you establish that? I will leave it that. And I will, one of you is going to ask me that question, and then I will answer that question as well. You have to establish that he is a returning adversary. And then you get his visibility about the tactics and the techniques, where he is in the state space. Now, as a defender, you can make the next jump and say that, oh, I'm going to let him do this. And I'm going to watch him and play a game with him. Okay? So with this note, I'm just going to come to the questions, and it's a fantastic being here. All right, questions, please.
Any question? Yeah.
Hi, I have a couple of questions.
Sure.
First is...
Yeah, could you please say your name?
Yeah, I'm Sambuddho.
Okay.
I have a couple of questions.
Sure.
First is, what you are doing seems like a glorified anomaly detector with little bit of signature-based detection.
I leave up to your interpretation.
It looks like, I'm saying it looks like to me.
Okay, no, come to your question.
So exactly how is it, so exactly the question is, how is it different from what you're doing, you're adding deep learning and reinforcement learning to something which the IDS community perhaps hasn't looked so far, and you're adding that dimension
Okay.
To make it more better, perhaps at detection. One, would you like to say some real scenarios to say, okay, if we have designed a system like this, what is the accuracy? What is the precision? What is the recall for this kind of detection? Second question is, I didn't see the. I am yet to see the what you said that you want to combine AI with with deception. I didn't see the deception part. I saw the AI part. I didn't see the deception part, or maybe I missed out the deception part really.
Sure. Okay. So I'm going to take your second question first. Okay. So your second question was you didn't see the deception first, right? So the deception part was when the adversary in the first scenario, where he gets into the SFO gamma host, how do you detect that? So that detection was actually one of the decoy. It was a decoy which was a high interaction and where the adversary got bumped onto. So that detection was based on a deception. So we actually detected that using our own deception techniques. So that is the deception being played. You watch that where the adversary right now. Okay?
You just said you did some deception, meaning perhaps you played out. For example, he logs into a shell, types some commands, but in a normal honeypot, maybe you can detect it, maybe by doing a reverse DNS lookup or something like that. But here you are saying, okay, you're doing deception to fool the attacker.
Yes.
That part, I mean, where is it? I mean,
okay. So
can you say a little bit more on the what kind of deception, the methodology for deception, the method you're using to do that deception, how you're really doing that deception?
Yeah. So what I'm saying is the defending part, like as a deception, how do we do that deception? I just left out that question as an open. I said you can use whatever technique and I don't want to make as a product talk. So what I'm saying is, you can use whatever deception techniques what you want to leverage as a defender, right? You may have certain open source deception techniques which you want to leverage, or you want to build on your own. I mean, whatever you want to leverage. I said, because I'm more of an AI guy, okay, and I'm just saying that my game starts when I got the signal, I got this alert from the deception. So certainly I didn't get into the depth of a deception here because I'm not a deception expert. I'm not a honeypot expert. So this talk was not really about the honeypots as such. I said what deception, you have planted the deception. The deception is giving you the visibility of where the adversary is. And that could be of many types. You could put the low interaction, you could put the high interaction, you could put the breadcrumbs in terms of a credential, RDP credential, you can put browser cookies. You can also introduce some specific vulnerabilities. It could be n number of things. And if you look at the deception market, I mean, it's a big thing in terms of the variety and in terms of the bandwidth as well, how you want to play out. But I did highlight a few things about a deception. The number one was, if you want the deception to be effective, it should be blending well with the environment. Because it can't be, if it is too obvious, then attacker will easily evade it. And the number two was, it should have a variety, so that it gives, the more higher probability of getting bumped onto them. And I would actually, the third thing is scalability as well. It should be scaled, right? It's not like you put a few honeypots and then wait for the adversary to come in there. That's not going to happen. If you want to make it to the real world, you need to have these three things. Okay? So let me get to your first question. How it is different than the initial approaches so far. So I have looked at the papers. I have not really included the literature survey part of it. Being a researcher, we always look at the prior art. So the prior art, what they do is, they have talked about more as a high interaction, where they look at the sequence of commands. And in those sequence of command, you actually model it as the MDP, Markov decision process. What we have done here is, instead of limiting just for the sequence of command, we have expanded the scope. It may look like an incremental, it's fine. I mean, what I think, being more of an industry guy, my perception is, can somebody use the things, in the enterprise or in the real world? So what we have taken is a generic approach where we will have the specific set of algorithms for certain detections. So in this case, I showed you a couple of scenarios where we used, they were not anomaly detection based. They were more on a supervised machine learning based approach. And the difference over here is the scenarios were such like we had the prior data available so that we could train the machine learning classifier. Now, otherwise, you can't really play a game, right? Because if the defender is taking too long to figure out the adversary's presence, then the game you can't really play. So you need to make sure, and that's what I'm saying is like you get that visibility, and plus the AI is actually telling you that what the noise is. You remove that noise, and you quickly point out what he is doing. Let's take some other questions. Yeah.
It was nice hearing this talk. I had
Could
a
you
question.
tell your name, please?
Yeah, my name is Dev.
Dave.
Yeah.
Okay.
So I was going to ask you a question, but you answered a bit of it yourself. You said that you had data and you trained your AI based on that data. You just said that. Right?
Sure.
From where did you get that data?
Okay.
Or if you did generate that data on your own, how many attack scenarios did you consider? Because training an AI engine requires a lot of data.
Sure. So let's pick up one scenario here. So let's say take an example of this PowerShell obfuscation detection. There are a whole bunch of thousands of PowerShell scripts are available openly. I don't need to really generate the data or something like all those scripts are available, thousands of them. In fact, Daniel was here last NullCon. He has a bunch of links to the PowerShell scripts. We started from there. It was like some 60,000 PowerShell scripts. We took a whole bunch of them. We used the Daniel's tool to obfuscate them using various type of obfuscations. I'm just getting into the detail for this particular example. And on his tool, he illustrates what kind of obfuscations are possible. All those becomes your class variables. And now you got the class variables with which I can train my classifier. And the feature engineering is something, your cup of tea as a researcher, right? You can use character n-grams, or you can actually use completely, don't even specify bigram or trigram. You go and start using the deep learning approach and, go from there. Or, you can create whatever features you want. But the thing is, we started with the open source data, leveraged the domain knowledge, in this case the obfuscation, and created got the class variables because we know what attacks we are doing, right? What kind of obfuscations are possible. Now if you say that, no, attacker can do the obfuscations on his own, I'm sorry, Dave, right? I mean, as a defender, I don't have that visibility, right? But as a defender, I know what are the popular tools being there, and what my understanding of adversary is like, they use the lay of the land, whatever things are there in the tools and techniques, they are leveraging that, right? And if they are leveraging one of these PowerShell obfuscation tool, then okay, we got it covered, we can detect them. More questions? Yes.
Hi, this is Suresh. I don't know much about AI. So my understanding is that AI in deep learning tries to mimic a human who is trying to learn something, right? So in this case, what percentage of human intelligence this AI is going to match up to? Because what is the human intelligence you are trying to mimic in this AI?
Yeah, Suresh, that's an excellent question, and you caught me right there, red. So let me define what I mean by AI first. AI is overarching umbrella of techniques where obviously you are leveraging more inspired from the neural network, where the machine's going to be mimicking the human behavior, as what you said as well. Now it has the deep learning, machine learning, and the data science, everything being there. Now, what I started saying, I think in my talk, what I illustrated, it started from saying that in order to do a AI, it is a stepwise process. In security, if you want to do, there is no such thing which is possible to really train, in a sense like in a game of a chess or in a game of Go game, you have the possible state space defined, what is all possible. And you can actually watch it and then play it, the game. And you can actually, the machine can learn from the human and it can do it. But in the security, I mean, it's so complex. The state space is not really defined, right? So what I made an attempt here is a step towards the AI. At least I defined the state space by saying the MITRE kill chain attack matrix, right? And from there, I picked up a subset of it and I showed a bunch of examples. And it works for other tactics and techniques as well. And what I said is, the problem is so big, we have to break it in a sub-problems. It's like, the dynamic programming we used to solve. Why the dynamic programming is so great? Because you are able to break the problems into sub-problems and then, then you connect the dots between them and get the global maxima, minima, whatever formulation you are doing, right? Whatever problem you are solving. And this is what is so fantastic here, that if we are doing a one step towards the AI, let's define the state space first, much more crisp. We define the state space, we define what's the defender's action space is, right? What he can do. Now, first of all, if we really want to get the AI over there, I need to get, even if I want to do a simulation, okay, just at a simulation level, I'm not getting into the real world. I need to at least define the things over there and then get into the simulation part. So here, what I've shown is a bunch of examples where it is possible right now is one step before that, able to say what is my state space, what are the things, I can watch my actions, and what are the defender things and all that. Now, the next thing would be actually taking it and doing a simulation as well. So I would point one of the source. So MITRE has open source, based on the MITRE attack matrix, that you can simulate the attacker, and the attacker is actually doing an attack based on the kill chain matrix. I just came to know recently, it is being there few months. So the next thing is, the Caldera. So now take that Caldera, right? And now bring the defender part of it and bring it to the game part of it. So it has to be built on an incremental. I agree with you. It has not, everything is not being shown today. It's a step. It's a steps towards that.
Thank you.
Hello. So guys, the time is out. So if you have any more questions, you can ask it offline. So who would like to change their desktops into gaming, gaming stuff like this? I wouldn't. But this was pretty cool talk. So now we are breaking out for lunch. This is NullCon, once in a year event. You have free and good food. Let's have, and after listening to his talk, I started to have a challenge. So challenge is with yourself. Let's go, have a food, and let's see how many of you turn up to the next events. Yeah, it's because people say that winning and losing is part of the game. But this challenge is only to you. You win, it's up to you. You lose, it's you. So you're not going to say. So let's see again, folks.
Thank you very much.
Thank you
for coming. Thank you.